Exercise 160 this is, 168. Question number 1. If we look at this function, first thing we might be tempted to do is to put it into autograph, and it looks horrendous, okay? That's because we've got loads of waves, so we need to zoom in on the x-axis, and also it's too high, so we need to zoom out on the y-axis. So we need to zoom out on the y-axis, which is this button, until we start to see the top of the wave, and then we need to zoom in on the x-axis to spread the wave out, and then hopefully start to see something that looks a bit like a familiar sine wave. There it is, okay? And in this particular question, we're asked to look at what's going on at 20 milliseconds. So that's 0.02 seconds. So if I go back to autograph, we're interested in what's going on at 0.02 seconds. There's 0.01. So if I drag this across here, I'll hopefully get to 0.02 around here somewhere, okay? So we can look at the wave. So let's put this in our notes, and we can use autograph to explore the function. So if we now look at this, there's the function. F is the frequency, and that's given us 250 hertz. Determine the rate of change of current when the time is 20 milliseconds. So here is the 20 millisecond mark here. So if the rate of change of current at that time, which is the gradient of the curve at that point. So as soon as I see rate of change, I don't just need to be in an exercise where I'm practicing calculus, so I know I'm going to have to do it, but that's why we do it, okay, because of the rate of change. So the function I equals 10 sine 2 pi ft. Pi ft, and the function is time dependent, so it could well have been written it, okay, because it varies with time. That's telling me straight away that this is the variable, so this is the number in front of the variable. So if I'm going to differentiate this, all of this is going to come out and go in front. So when I differentiate it, I prime t now is going to equal 10. So we're going to bring the 2 pi f out of the function. The sine is going to change to a cosine, and the rest stays exactly the same, okay? So that's effectively what we're doing. So 10 times 2 is 20. So the differential function is 20 pi f times the cosine of 2 pi ft. We're now told that we want to find I prime t when f equals 150 and t equals 20 milliseconds or 0.02 seconds. So I can put those values in here. So it, or I prime t rather, equals 20 pi times 150 cosine 2 pi times 150 times 0.02. So it's the cosine of all that lot. So that's what I'm putting in, effectively. Tidying up. 2 times 150 is 300, so 20 is 3,000. Pi cos, whatever that comes to. 150 times 2 is 300, so times 0, that's 3. 3 times 2 is 6 pi. Okay? Look at the cosine function. This is 2 pi, okay, isn't it? And the cosine of 2 pi is 1. So what's the cosine of 4 pi? What's the cosine of 6 pi? So that's 1. So therefore I prime t equals 3000 pi. Okay? Unit amps per second.